I am Priyanka, Assistant Professor of Computer Science, Sri Bharathi Arts and Science College, Perman, Kaikurchi. I am going to explain the topics in compiler design. Compiler is an overview. Compiler design front end is what is compiler and lexical analysis, syntax analysis and parsing. And compiler design back end is code generation, register allocation and optimization. The specific examples of compiler Lex, OIAC and LCC. What is compiler? Compiler is nothing but adding two numbers and move numbers from one location to another, move information between CPU and memory. These are the examples of task of compiler. We do the task in everything, and software translator is also the compiler thing. Then lexical analysis. This lexical analysis is the first phase of compiler. Isolate the words and tokens. Words we are knowing, and tokens. Tokens, what is meant by tokens? We have the examples: keywords, identifiers, operators, numeric, character constant, and special characters and comments. Keywords means while, procedure, where, and so forth. Identifiers declared by the programmer. Operators, the symbols of numeric, plus, minus, asterisk, like that. Numeric, numbers such 1 to 4 and 1 to 0.35 and 0, etc. And character constant and special characters and comments. These are the examples of tokens. This is the first phase of compiler. Next phase is syntax analysis. What is syntax analysis? It is the second phase of compiler, also called parser. We have to clarify about what is parsing problem and how is the parsing problem solved. We can see that. We can solve the problem using top-down and bottom-up algorithms. What does it do? One method. Push down machine. Example, consider the simple grammar is clarifying S0, S1A. Then we can isolate from the 1 to another one S10A. And we are going to isolate from A0, S0. And we are going to isolate A1. Procedure to construct pushdown machine. The pushdown machine have a basic terminal example. That is how build a table with each column labeled by a terminal symbol and each row labeled by non-terminal symbol. That's it. Then for each programmer rule, the grammar rule form A and fill with the cell in a row and column A with a rep, where A are represented at reversed. Fill in the cell in a row and column with pop for each terminal symbol A. Fill in the cell in row and column with accept. Fill in all other cell with reject. Initialize the stack with and the starting terminal. The overall process is constructed by pushdown machine. This is the basic example of this. Next, bottom up. We will discuss in bottom up parsing. What does it do? The basic operations of bottom up parsing is shift operation and reduce risk operation. Why split the compiler first? Why? The first we are going to split the compiler. That means front end is machine dependent. Front end can be written in high level language. Reuse oriented programming. Back end is machine dependent. Lessons time required to generate new compilers. Make developing a new programming language simpler. Then this is why we split the compiler. Front end is a machine independent, back end is a machine dependent. Then we can be written in high level language in front end. We can be written in back end language in back end. Okay. Then code generation. Code generations means nothing but convert functions into simple instructions. That means simple and complex. How to addressing the operands? These are easy to weigh in base register and offset and examples. Single pass versus multiple pass. Single pass means create a table of jump instructions. but multiple passes, no fix up for table. Single pass, forward jump locations are generated incompletely. Multiple pass, in the first pass through the inputs, CG does nothing but generate table of labels. Jump addresses entered into a fix up table along with the label they are jumping to. This part a single pass. Multiple pass, since all labels are now defined, whenever a jump is encountered, all labels already have predefined memory locations. Register allocation assigns a specific CPU generated process specific values. Then compiler must maintain information on which register are used for which purposes, then which registers are used available for reuse. The main objective is maximize the utilization of the CPU register, minimize the reference to many locations possibles for CPU register, that means values used many times in a program's value that are computationally expensive. Why? What is the importance in the register allocation? This is efficiency and speed. Then an examples of having simple register allocation and smart register allocation. The scheme explained here: A equal to B plus C asterisk D and B equal to A minus C asterisk D. These are the examples of two statement program segment. Then register allocation algorithm. What is meant by register allocation? That means RAA determines how many register will be needed to evaluate the expressions. That means we are going to evaluate the expressions. We have some register to store. So we have register allocation algorithms to take a easy method. Determines the sequence in which sub expressions should have been evaluated to minimize the register use. Then how does the RAA work? These are the simple way to work. Construct a tree bottom is like tree leaf that. Then assigns each leaf node of weight. 1 if it is the left side, 0 it is the right side. This is the format to create a tree and a leaf node. The weight of each program node will be computed by 2 children like that. If the 2 children have a different weights, take the max. If the 2 weights are the same, the parents' weight is W. The weight is denoted by W plus 1. That's all. Examples of R way is displayed here like a tree way. In optimization, global and local. Global means directed by acyclic graphs. Local means load star approximation. These are the examples that have been belongs to tree method. The main problem with the optimization techniques is debugging is more difficult. We are going to face the debug part, that part is very difficulty part in that way. Programs to be discussed. Already we have the example. We already see the examples, right? Lex, YACC and LCC. Lex means it's a program utility generates by a lexical analysis. Y-axis means parser generator and LCC means ANSI compilers. That's it. And platforms. All 3 programs designed for use on Linux. Then LCC runs on the DOS and the Unix. Then lexical programming utility. The general information is here. You can read it. Input is stored in a file with a extension. File consists of 3 main sections. And Lex generate she function stored in Lex. The using Lex of here to be specify the words of token and then run on the Lex utility. Then declares global variable. The 3 sections of input file. These are the examples, sections of example here. Then general informations of YAS. Okay, input is a specific of a language, output is a compiler for that language. These are the general information and using of YAS is here. These are the part of YAX source and this is the parser to generate input source file, declarations and ports for 4 parts. Our output item is here. Operations, left operand and right operand and the result. And of course the LICC compiler here. These are the examples of syntax trees and how to generate a register and assembler template. Then the conclusion, compiler wrote of backend and compiler front end and specific examples. This is the reference of books of compiler. Thank you.